Hello, chemistry students. It's me, Mr. E, with another in my series of videos on how to fall asleep while looking at Canvas. No, that's not it. Okay. This one is on Lesson 5B, Density and the Gas Laws. So just a reminder, density, we're going to be talking about mass and volume and what they are. And here's the units. And we have a new thing we're going to do now, which is worrying about these things called milliliters and centimeters cubed. Okay. They're the same size. When we talk about solids, we tend to use centimeters cubed, and we talk about liquids, we tend to use milliliters, and then you know what you're talking about right there. So density really is just how much stuff you can jam into a space. It's got two units. It has to tell you the units of the stuff, in this case mass, how many atoms and molecules you have, and it's got to tell you the unit of the space or the volume. And we're going to be using either centimeters cubed or milliliters for solids and liquids, and for gases we're going to use liters. Here is the formula, basically, is that density equals mass divided by volume, which is what I have right up there. This is a little helper triangle, and I've used those before, and what you do with them is if you can't remember which one you're solving for, you just cover up the one you want, and then it shows you the form. So that's mass over volume, you divide. If you want volume, you divide mass by density. And if you want mass, you multiply density times volume. So it makes it pretty simple. So you just do that. Okay, so here we go. Example number 1, going to go through it. Here's your mass right there. 1 decimal place on that. It gives you the dimensions of the block, but it does not tell you the volume. Remember, the volume of a solid is length times width times height. Doesn't matter which one is which. Multiply them together. Centimeters times centimeters times centimeters is centimeters cubed. That's what you get right there. And then you just set it up. Density equals mass over volume. And right here, you've got 2 units. I made a mistake, put 2 places on there. But I'm reminding you here, it's a 2-unit answer. So I divide 1896 by 212.5, and I come up with 8.9 grams per centimeter cubed for that one. Okay. Let me see, they're kind of messed up. Okay, so if you can't cancel the units, I've been showing you that little method right there, then you just have to write them both. So that's what you do. So here's example 2. Now we have a density given and we know the volume. So what do we need to do? We need to find the mass, and mass is simply equal to density times volume. Multiply them together. I'm showing you the long method right here that when I do this, those guys cancel and it leaves me in grams, which is what I want for the mass. You have to remember to do that. So I just multiply them together and I come up with 55.96, and I'm trying to be real consistent. 2 decimal places there, 2 decimal places there, 2 decimal places on the answer. Okay. Number 3, so now we are looking for volume. I've just gone through and solved each one. So volume is going to be mass divided by density. There it is right there. The density is 0.8765. Notice I tend to go more decimal places when the number's smaller than 1. I just do that to get enough digits in there. So there's that. There's the mass to 2 decimal places right there. Volume, divide them. And again, kind of weird, but grams over grams cancels, leaves milliliters. There's my answer right there. And I've got it. So that's the density problems. Those are pretty simple. I think you've all been able to do those in the past. Quick little thing on density, because what's interesting about this and how it ties into gases is this little idea right here, that you can change the density of something. If I have 2 things that are the same size, I can change the density by adding more molecules to it. And so now I have more molecules for the volume, so I have a greater density right there. The other thing I can do is I can change the volume right there. So thinking about gases, I could have this space right here, and then I could pump more gas into it, and I could increase the density if I don't let it expand. Or if I just have 2 and I can squish it, now I have a greater density right there. So there's a couple different ways to look at density and what's going on there. All right, so now, and that's what this is talking about right here, kind of going through some long details, and that is that as long as it's in the same phase, the density stays the same. Okay, it doesn't matter if you have a little piece of copper or a sheet of copper. Copper is copper is copper. When it's a solid, it all has the same density. So, but when you add energy, which is what we started talking about, now you're going to change the particles and their energy, and you're going to want to make the volume expand. Same number of particles in a bigger volume makes the density go down. Okay. What we're looking at right now are gases, because you can really change these things. You heat up a solid, it doesn't get too much bigger. Most liquids you do get some change, but with a gas, it can really grow. So I've tied that in right here, and so we're going to do two-step problems right here. So we're going to do gas calculations and density. Either going to do the gas calculation first and then use the density, or do the density first and then calculate the gas. So we're always going to put stuff in atmospheres for pressure, volume in liters, temperature in Kelvin to do the gas problems, and gases are usually in grams per liter, not grams per milliliter, because gases have so much greater volume space between particles. So here we read it. This tells us solve for volume, then calculate density given the mass right there. So if we're solving for volume, we're going to have to use the gas law first. All right, let's see what we have. Oh, I see pressure and I see volume. So that tells me that's Boyle's law right there. So there they are. There's P1, there's V1. Now I got to look down here and see what's going on. It tells me if the pressure is increased, that's P2. And I should have said this and I didn't, but calculate the basically new volume of the gas when you increase the pressure. So you're going to do that. You're going to do a gas law problem first. Then you're going to take an answer and use it to calculate the density. So that's your second calculation. So to do this, I need P1, V1, P2. V2 is actually going then to be the V for my mass. And I'm going to calculate the density. It's going to be the V to go with my mass right here. So here's what I do. I see my information right here. I write it down, 1.23 atmospheres. Milliliters are simple. Just divide them by 1,000 or move the decimal 3 places to the left. So 1,234 becomes 1.234. Just do that every time. There's my V1, there's my P2, so they're both in atmospheres. I don't have to worry about it. There's my V2. So here's my setup right here. P1 times V1, and there's P2. V2 I'm looking for. Bring this over and divide it, and that's going to give me 0.333 liters. Okay, so my answer is more than 2 decimal places, and I tend to do that with numbers that are less than 1. The key is I have to bring this volume down now and use this in my calculation down here. So here's my mass, 0.466 grams, which I got from up here. I bring my volume right down here, and I'm going to divide that, and I'm going to get 1.40 grams per milliliter. Okay, on example number 2, right here, there it is right there. Now this one says solve for volume, then use density to calculate mass. So I'm still going to do gas laws first right there. So I'm going to do gas law, calculate the new volume of the gas, then calculate the mass of the gas if it has a density right there. So I'm going to do that second. I read through the problem. I see I got a T1. It's already in K. I've got a V1 already in liters. I've got a T2 in Celsius. So there they are right there. V1, 21.3 liters. T1, 305.6 K. V2 is what I'm looking for. Calculate the new volume right here. So that is my V2 right there. And T2, I'm going to add 273 and get 372.5. Here's my setup right here. All right, so basically what I'm going to do is just bring the K up over there, multiply it and divide, and I'm going to get at 1 decimal place. I want 1 decimal on all of these. So at 1 decimal place, I get 26.0. Look what I had, 25.9629 to go to 1 decimal. I round that up, carry it to 26. Then I bring this 26 and I bring it down here, boom, that's for my next calculation right there. It wants mass, that means I multiply, density times volume right there. I do that, again, science nerd, the liters cancel, leaves me grams, and there's what I get. I had 81.12, and at tenths, staying at tenths, I get 81.1 grams, okay? Coming down to example 3 now, right here. Now this one says that what we're going to do here is use density first, okay? And then we're going to use the gas law. And it's all written in one problem, so we got to look through and go, okay, we need density. So here's the mass for the gas. there's the density right there. So we're going to have to use those to calculate V1. There's the mass right there. We want V for V1. There's the density right there. We could solve that right away. Bring that in here, 246.8 divided by 3.79. And I'm going to go 2 decimal places because when I look through my problem, I see everything is to 2 decimal places. On the quizzes, I'll tell you how many. That's where students go wrong a lot. But here, I got 65.118, so that makes it 12. There's my number I'm going to use in my next calculation. My next calculation is I need to solve for V2 using Boyle's law. This V is my first V right there, so I bring that down right here. Boom, 65.12. Here's my P1, 6.54. It wants the new volume. There's my V1, and the pressure right here is given in millimeters of mercury. I divide by 760, that gives me atmospheres. Here's my setup, P1 times V1 equals P2 times V2, divide by 1.55, and that gives me 274.76 liters, and I had 7644. You can see how that divided. Okay, moving on. Now here's the practice problems. We got 2 problems on the quiz like this. Okay, and on those, all you can do is give me 1 answer. So I'm going to try to show you how to go about doing it and make sure you're correct there. So I'll do my teacher cover-up thing right here to start with. So first of all, we see this right here. And so we see our density right here. We see we have a mass. This is our first temperature. Not quite sure yet, but I know that's at first temperature is a T1. Okay, calculate the new volume. So that's V2. If the temperature is raised to 25 degrees Celsius, so that's my T2. I didn't say it in the problem, but what you need to do is use density to calculate V1 right there, or V for that. And then you're going to use Charles' law to calculate V2 right there. So when you convert, you can remember to convert that when you'd go with that, okay? So here's what we're going to do. First step right here is we're going to do density, use density, and then we're going to go for the gas. So for number 1, right here's our mass. Here's our density right here. Notice I went more than 2 decimal places on that. And I want to find the volume. So it's pretty simple right here. Volume's mass divided by density. Divide it. Get that. I get 233.9119. So I'm going to call that 233.9 because I had 1 decimal place there. And these tend to be more. So I put that into my V1. And I come right over here and I'm going to use that. So there's V1, 233.9 over my T1, 273, V2. I brought my 25 down here and added 273 to give me 298. I'm going to bring that up there and multiply that and divide by 273. And that's going to give me 255.3 liters. I just went 1 decimal place on that. And there's what I had to start with, 3194. So the 9 doesn't affect anything, and that leaves me at 255.3 for the volume on that one, okay? On the next one right here, now we're going to look at this. We're going to see we have 7.26 grams of a gas, so that's mass, with a volume. Oh, so that must be my first volume. That's a V1 right there in milliliters. So I'm going to have to convert that. It's at a pressure of 2.20, so that's P1. Calculate the new volume. That I don't know. And the pressure increases to P2. And so then it wants me to calculate the density. So I have the mass. I'm going to have the volume. And then I can use that one in the next calculation. So here's this one right here. So I'm going through, there's my information, and these are harder because you got to read through, right? I got to pick that up. There's my P1, 2.20 atmospheres. Here's my V1, it's in milliliters. Divide by 1,000 or move the decimal 3 places to the left. 1, 2, 3. Do that every time. Here's my P2, divide by 760, I get 5.80. I'm looking for the volume first, right? So that's what I'm looking for. Calculate V2. So there we go, P1, V1. P2, V2, right there, solve for V2, divide by that, I get 3.74 liters. I got 737, round it. I tend to go 2 decimals, sometimes 1, never 3. So there's my volume. Now I'm going to use that in my mass calculation. 7.26 grams divided by 3.74 gives me 1.94 liters at 2 decimal places. And the last one right here wants the mass with a density. Okay, wants to know the mass. But first of all, okay, if the gas is at a temperature, calculate the new volume if the temperature is lowered. Okay, so calculate the new volume, the density. All right, we already have the volume right here. This one's a little bit harder, but really it's just making us do two separate problems. One doesn't really have to go with the other one. So for density right here, we need to find the mass, right? We have the liters right there. So this is actually going to be our V1, and that's going to be for that. There's our density. Mass is what we want. The gas is at a temperature, so that's our T1, and that's in degrees Celsius, so we're going to have to add that. Calculate the new volume, V2 we want, and the temperature is lowered, and that's our second temperature. That's the hardest thing, I'm telling you, figuring it all out. So here it is right here, okay? Okay, so here. Now what do I have? There's my mass right there. Here's my volume, 531.97. There's my density. Mass is equal to density times volume. I multiply them out and I get 3117.34 grams right there. And there's my bigger number. Down here, it's a separate problem. I don't need to carry anything down. I just go back, I use the volume again. I add 273 to get my K. I add 273 to get my K right there. I'm going to cross multiply that right there and divide by 40.89. And there I go. And I get 250.81 at 2 sig figs. So there you go. I hope this helps. I might do another one on the quiz, but practice this stuff first.